Okay guys, we're going to try a slightly different format here. I'm doing this on the iPad, and the writing looks a little sloppier this way, but it's uploading to YouTube a lot faster than what was happening before, so we're going to run with this. So the question I was asked was for D&S Exam 2, problem number 10, which says that for x in between 0 and pi over 2, an antiderivative of 2 tangent of x is, and we're supposed to figure that out. So what I'm hoping I'm not giving away right here is that when they're asking for an antiderivative, that's really just the same thing as doing an indefinite integral of that particular function. So let's get working on this one. First thing I'd probably do is bring that 2 out in front of the integral sign right here. And with the tangent of x, integrating tangent is a lot harder than it sounds, but we have talked about how to do this. This was one of the examples we did back in the section where we first did u substitution way back in the day. U substitution worked when we were trying to do an integral of two different functions, two distinct parts to the integrand that were related to each other in some way. And in this case right over here, if we switch the tangent of x up into sine of x over cosine of x, then as we very often do, we're going to go to the denominator of that rational function there, or that fraction I should say, and let that be where we get our u from. So if we're going to let u equal the cosine of x, then we would differentiate this equation here and get that the derivative of u is the opposite of sine of x dx. And that almost perfectly matches our leftovers on the secondary substitution. We're just going to bring that negative to the other side and make that a negative du is equal to a sine of x dx. So back to the problem at hand right here. We already had a 2 out in front. With that secondary substitution giving us this negative, I'm going to bring that negative out in front here and say, okay, that's negative 2 times an integral of, we've got a fraction now, the denominator, the cosine of x, is our primary substitution. So all of that just becomes u. And the leftovers right here, the sine of x dx, that got replaced by the negative du. I already put the negative out in front, so I'll put the du here at the end and go with a 1 right over there. Okay, and since we are now anti-differentiating a constant divided by a linear function, this is where our antiderivative is going to have a natural log of the absolute value of your denominator, u. I'm going to go ahead and kill two birds with one stone right here and change that u back to a cosine of x in the absolute value there and put a plus c at the end of all that. Now at this point right here, if it were a free response question and you stopped at this point, you'd get full credit for that answer. Everything here is correct. But what I'm guessing bothered some people about problem number 10 is that this particular option right here, what we have written, is not one of the 4 choices for our answers. So there's a couple of things that they did here as we went through all of this. The first thing to be aware of is that none of their answers has a negative 2 out in front. So what they did is took advantage of that little trick with logarithms that says that a coefficient in front of a logarithm can get moved to be an exponent on the product itself. So I'm writing that as natural log of the absolute value of the cosine of x to the negative second power and a plus c. Now that is closer but not quite right with what they did next. The next thing that they noticed, or that they did right here, is rather than taking cosine to a negative exponent, they decided to flip that around a little bit and make that the natural log of the absolute value of, and that's going to become a secant squared of x inside the absolute value right over there. Secant squared of x, close it, and a plus c. Now, the one thing that they didn't do right there, they didn't include the absolute value in their answer, and that gets back to the very first thing they said at the beginning of the problem. X is bound in between 0 and pi over 2, so we know that everything we're dealing, whether it's sine or secant or tangent or whatever, all has to be positive because we're within the first quadrant. And they decided to just ignore the plus c at the end, treating it as a 0, so the answer then is the natural log of the secant squared of x, and the answer to number 10 is B.